Hello everyone and welcome to Kiru's online lectures. I am Kiraj Jamtani and today's topic is Aromatic Hydrocarbons Part 2. In Part 1, we studied introduction about benzene and how to prepare benzene. In this video, we are going to study about the physical and chemical properties of benzene and directive influence of benzene. Now coming on to physical properties of benzene. So aromatic compounds, they are non-polar compounds and usually they are colorless liquids or solids with a characteristic aroma. Aromatic hydrocarbons, they are immiscible with water, but yes, they readily mix with organic solvents. The third physical property is they burn with a sooty flame. So this is all about their physical properties. Coming on to chemical properties. So these aromatic compounds, that is benzene, it shows two types of chemical properties. The one is electrophilic substitution, other one is addition reaction. Electrophilic substitution, there are some steps involved in electrophilic substitution reaction. The first is generation of electrophile, then formation of carbocation intermediate, and the third step is removal of proton from the carbocation intermediate. Like the first electrophilic substitution is nitration. This is benzene with us. This is a benzene compound and we are performing nitration over here. So when we are performing nitration, we will take nitrating mixture. Nitrating mixture is concentrated HNO3 plus concentrated H2SO4. So thus over here we will get the nitro group will be attached by the removal of hydrogen. This nitro group attached and thus we got nitrobenzene. Second is halogenation. We are again taking benzene. So when we are taking benzene, halogenation we have to perform. Halogenation is done with Cl2 and anhydrous AlCl3. So chloro group will be attached by the removal of hydrogen. Thus we will get chlorobenzene. So this is how halogenation and nitration of benzene is done. Next is sulfonation. For sulfonation, we have to take again sulfonation के लिए we will take fuming sulfuric acid, that is H2SO4, thus SO3. So thus here what will happen? SO3H group will be attached by the removal of proton from the benzene. Here SO3H group is attached plus H2O. This compound is known as benzene sulfonic acid. Friedel-Crafts alkylation. So we have benzene. Now when we have to perform Friedel-Crafts alkylation, we take alkyl halide, that is CH3Cl, in presence of anhydrous AlCl3. Again here H from here and Cl will be removed. So CH3 will be attached in place of H by the removal of proton. This is known as toluene. Coming on to next, Friedel-Crafts acylation. So when we are performing acylation, for acylation we require acetyl chloride CH3COCl. So this Cl and proton will be removed plus HCl. COCH3 group will be attached to the benzene ring. Thus this is acetophenone. Again this reaction is performed in the presence of anhydrous AlCl3 only. Next is benzene on treatment with excess of chlorine. Again in the presence of anhydrous aluminum chloride only. In dark we get hexachlorobenzene. So this is again a substitution where 6 protons are removed, in place of that Cl is attached. So plus 6Cl2 will get over here Cl, 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 Cl and Cl. This is known as hexachlorobenzene plus 6 HCl molecules are removed. Coming on to addition reaction of benzene. So first we'll perform the addition of hydrogen. we have benzene over here. When we are adding hydrogen in presence of nickel, platinum and palladium along with the heat, we will get cyclohexene. Similarly, if instead of hydrogen we are adding chlorine, which is known as chlorination, and when addition of hydrogen is performed, it is hydrogenation. Along in the presence of UV rays at 500 Kelvin, we'll get benzene hexachloride. So this is how. Now coming on to directive influence of functional groups in monosubstituted benzene. So we have two types of directing groups. The one is ortho and para directing, that is called activating group. Other one is meta directing group and deactivating. Like let's suppose we have over here OH, NH2, NHR, NHCOCH3, OCH3, CH3, C2H5. These all groups are, whenever they are attached to the benzene group, and then further substitution process we have to perform. So these are ortho-para directing, that is the incoming electrophile will attack in ortho and para position only. But there are certain meta directing groups like we have NO2, CN, CHO, COR, COH. These groups are meta directing group, that is deactivating group, that is the incoming group attaches to the meta position. Coming on to carcinogenicity and toxicity, benzene and polynuclear hydrocarbons which contain more than two benzenes like anthracene and all, these rings fuse together and they are toxic, and thus they possess cancer producing properties. Therefore they are called as carcinogenicity, which are very toxic in nature. So in today's video we studied about physical and chemical properties of benzene, and we also studied directive influences of monosubstituted benzene. Hope you guys are finding videos helpful. So do like, share and subscribe the channel. Thank you.